用吗？
对，人用，那是人用。
现在没到。
人用，人用到了，
就是到哦，
人用。
Hey, good morning, everyone. Last week we have talked about technology and engineering rights, chapter 1. And today, before we start the new chapter, our teacher Corey, he will do like a summary of chapter 4 about the robots. Okay, so later he will introduce something very interesting and latest stuff about robots. Okay.
Okay.
So yeah.
Okay, so first of all, we're going to talk a little bit about the history of robotics and how it kind of came to be. But before we do that, we need to have kind of an understanding of what is a robot. And so I have a question for you. It's on the first slide. With your partner, you know the usual. Please just discuss with your partner what is the difference between a robot and a machine. You know, we know all robots are machines, but not all machines are robots. So what is the difference? So please with your partner discuss for about 1 minute.
在干嘛？
robot 没有物理上的动。
那个机器是。
对。
卡尔，大错误，卡尔。
Good answer. You got a good answer. Okay. Also using the phone for definition is
Machine people. 一个扫地机器人没有那个。
Okay, so I'm curious. What answers did you come up with? What is the difference between a robot and a machine? Did you have any answer? They're shaped differently. And so how is a robot usually shaped? Okay, so that's one important characteristic, is that a robot, usually or often looks human, especially in this picture, the Star Wars one. So humanoid, looks human shape. How about somebody else? Do you have anything? A robot can move. Sometimes machines, they don't move. Yeah. So robots can move. Did you have a good one?
Robot is a machine.
A robot is a machine. Okay.
Okay.
But how about Carter? What do you have?
Robot is a machine, and machine is not a robot.
Okay, yes, that's true. Sorry.
Autonomous operation.
Autonomous operation. Yes, very good. So I'm going to write down the word. Actually, that's a very good word. I can erase this, right? Just erase this. Autonomous operation. What is? I think I told you this word before. Autonomous. We've seen it in a magazine before. Autonomous. What does autonomous mean? I think it was we were doing Basque County as an autonomous state. Do you remember? Yes? Or no? No? It's okay. Yeah. How about auto? Do you remember? Pardon? Yes? No? What does it mean?
Work by itself.
It works by itself. Yeah. So when we were doing Basque County in Spain, it's not ruled by Spain, it rules itself. It works by itself. Auto means self. So a robot can work by itself. Operation obviously means taking action, working. So yeah, that's actually, I think, a pretty good understanding, a pretty common understanding. Yes, robots can look human, but actually the first robot didn't look human, the first modern robot. So yeah, but this is something that it can work by itself. And now, there's something that's very interesting. What does it mean to work by itself? This is very, people have differing opinions about this. So for example, I was looking at what are the first robots, and there's many different opinions, but I found something very interesting. In the 18th century in France, I don't know why, but they had extremely skilled watchmakers and clock makers, people who made clocks. And they had something called automatons. You see that word auto again. Whenever you see auto, it means self. Automatons were these people looking, or they look like people, but they moved and acted when you cranked a kind of lever. And it's not, there's no electricity here. There's no electricity. And they could do things like actually draw a picture. And all you're doing is cranking a lever. Very advanced, very fascinating, and I kind of want to show you a video of it. And you can decide for yourself if this counts as a robot. But first we'll have to watch an advertisement because of capitalism.
That something from the late 1700s to captivate today's youth seems as miraculous as the device
他写
itself.
的 review 写的漂亮。
This elaborate wind-up machine called an automaton, which writes and draws, is in many ways a mystery, even centuries later.
So I just wanted to show you just how impressive. I mean, if you watch the full video, they have to crank it. There's no electricity, and it can write actual poems. You know, with better handwriting than any of us. And it also writes, or it can draw pictures. Very complicated, and actually, it's a mystery how they made some of them. Some of them were so complicated, people don't even know how they were made. Now, is that considered a robot? Anyone think that would be considered a robot? Yes, no, maybe? No? How about, do you think that would be considered a robot? Yes, no? Don't think so? And why not? No electricity, right? No electricity, no, you know, it does move by itself. It accomplishes a specific task by itself. But almost all other robots we can think of were, you know, had electricity or were powered some way by electricity, whereas this is just a bunch of disks actually that are powering it. But it's still, I think, pretty interesting, and it's up for debate, really, if that's considered a robot or not. Okay, but we do have robots today, even in our own home. Cleaning floors, there's a robot that cleans your floors, you probably know of these. What you may or may not know is that robots are actually used for building cars, for doing things that humans can do, but it's a little bit dangerous, so for like welding. And this robot here is actually a more modern version, the building cars robot, is a more modern version of one of the first robots that ever really existed. And as you can see, it doesn't look human. It doesn't look human, but it is called a robot because it has autonomous operation. And so here's, I found a couple different definitions online. And here's one that I like. Robots are machines, you know, as was said, Carter and Ian said. Robots are machines, but they use their programming to make decisions and carry out specific tasks. So they're more complicated than a machine. Because they can actually make decisions. And you know, the automaton, does that count as making decisions or not? That's kind of up for opinions. But that's what a lot of, you know, everyone agrees on a definition. A robot has this, as Han said, autonomous operation, and it's autonomous because it can make decisions. It doesn't have to speak, it doesn't have to look human, but if it can accomplish a specific task and it's making decisions using its programming. Some other vocabulary that's good to know. People who study or specialize in robotics, we call them a roboticist. A roboticist. There's also a robotics engineer. I tried to find the difference between these two, and I couldn't find the difference. And so people use both terms. I don't know if they're the same. You'll have to look this up, I guess, yourself. But I don't know. But I know if you want to study robotics, you know, they would refer to that person as a robotics engineer or a roboticist. Something else that's pretty important. If you want to study the field, it's called robotics. It's not. The S is very important because if you take the S out, robotic means it's like a robot. And this is pretty important because if I say I'm a robotics engineer, that means I'm somebody who makes robots and who studies robots. But if I say I'm a robotic engineer, that is somebody who is a robot, not a human being. So the S is very important. Okay, let's take a look at, first of all, where does the word robot come from? Obviously, you know I like literature, so when I found this out, there was a play all the way back in 1921. Before 1921, the word robot did not exist. And people would refer to machines that look like people, they would refer to them as automatons, you know, like the dog. But the word robot was actually used in a play by a Czech writer about people who, they weren't even machines really, but they were created. People who were created, they were referred to as robots. And it's a very, 1920s, people were very superstitious about science. I talked about this last time in my remote control lesson. You know, when Nikola Tesla was able to control a boat in 1898, people thought, oh my God, he's going to control people with that device. So people were very scared of science and technology. And in this play, the robots all murder everyone. And so it's interesting that this is where the term comes from because it was a very popular play, And eventually people started using robots, the word robot, to describe any type of being who was created, usually with machines. And you see it in one of my favorite short story collections. This is published in 1950. It was called I, Robot by Isaac Asimov. Really, really interesting sci-fi writer who tried to humanize robots. There's maybe 9 stories in here. They're pretty brilliant. But in 1950, it was pretty common to refer to a robot as a machine person. You know, a person who was who's created and made into a machine. Now, I think actually, so this was published in 1950, but 1 year later in America, we actually had the first real robot. The first industrial robot. Now, of course, you can argue, what is the first robot? You know, is it the automaton? Is it Nikola Tesla controlling the boat? But the first modern robot, the first industrial robot that actually was used not just to entertain people or used as a kind of you know, thing to get people excited about technology, the first robot was actually called Unimate, and it was invented in 1951. It welded parts of automobiles. You know the word welded, weld. You know, when you have 2 metal parts and you want to make them stick together, you have to use a lot of heat, right, to get them to stick. That's welding, when you're trying to connect 2 metal parts. So it's something that's very important in when putting cars together. It's important, but it's also dangerous, you know, very, very high temperature. And so this robot was the first robot that was sold to, I think, General Electric, or I forget exactly the company, but it was sold to them and it was actually used in factories. And even today, there are modern versions of this robot, modern versions that can perform dangerous tasks with more accuracy and speed than people can. So this is the first example of robots replacing people. And this is, I think, another part of the definition of what is a robot is that things that we do, robots can, you know, try to replace them. We try to replace them with technology. And so something like this, dangerous welding. And so this was Unimate, the first robot, which was in 1951, but it didn't really become really popular, I think, until the 60s. It was found, it was, you know, put in a lot of factories. Okay, good. In the 1970s, there was the first, I would say, humanoid robot. The word humanoid here, I've been using it. It just means it looks like a human and it's shaped like a human. So again, the first robot didn't look like a human, but in Japan, in Waseda University in 1973, they actually really tried to make the robots like in the sci-fi stories of them walking and picking things up. So it could walk, it could pick things up, it could measure distances with its sensors, but one step took about 45 seconds. But this is still, it was pretty impressive. We couldn't use it like Unimate, we couldn't use it in factories, but it was still impressive that they could do this. And ever since then, Japan has been really trying to push robotics and to achieve things in robotics. And in fact, if you want to study robotics, Tokyo University is, I think, ranked number 3 in the world for robotics. Actually, that is the next slide. University of Tokyo, yeah, ranked number 3 in robotics in the world. So if you ever want to study, it's not that far away. I think number 2 was MIT in America, and then number 1 was Carnegie Mellon. Of course, all of this information, I found it in English, so maybe it's a little biased. But Japan has been producing, robots, ever since again the 70s. So it's something they're very interested in, and they, if you ever wanted to study in the university, if you ever wanted to study, it's not that far away. Okay, and so in the 70s they made humanoid robots, but still they couldn't commercialize them. In the 80s, again, we have had a lot of sci-fi technology and a lot of interest in robots, people putting money into robots, not just because they could do things that might be too dangerous for people, like with Unimate, but also people want robots to fold their laundry, clean their houses, so in the 80s people were really interested in this. There was a roboticist in the 80s. His name was Moravec. He's Czech also, lots of Czech in this lesson. And he came up with a concept trying to explain, kind of why, or help us understand why don't we have robots that can do our dishes or do our laundry. And his paradox is this. Oh, I'm sorry. Let me explain the word paradox. Have you ever heard this word before? Paradox. This is a very good word to know. I guess I can write this. Try to write it. A paradox. Maybe that's how you read. Anyone hear this word before, though? No? Okay. A paradox is when you say something and it has two opposite ideas in it, but it still kind of makes sense. So I'll say it's a statement that has two opposite ideas, but it still makes sense. But it makes sense, or has a kind of logic to it. So, for example, a famous paradox. I don't agree with this, but someone might say, someone might argue, sometimes we have to go to war to have peace. War and peace are opposite ideas, but there's still some logic to what they're saying. So that's a very famous, famous example of a paradox. So Moravec has a paradox here. I'll give you the first part. I want to see if you can guess the second part. He says, what is hard for humans is easy for robots. For example, welding. Difficult for humans, but it's easy for a robot. What do you think is the second part? What do you think is the second part of that paradox? Anyone have an idea? Can you guess? What is hard for robots? So what is hard what is hard for robots? Yeah, you got it. Good. So Enoch said, what is hard for robots is easy for humans. And it's actually, it's the same meaning, but you changed the words a little bit. So again, the first part is what is hard for humans is easy for robots. And then he said what is easy for humans is hard for robots. So you just reversed it. But yeah, so this is a paradox. It has two opposite ideas. But more importantly, you would think if a robot can do things that we can't do, shouldn't they also be able to do things that we can do? Well, it's not true. It's not true. So this is what makes it a paradox. So a robot can lift really, really heavy things that humans cannot. But here's a picture of someone actually folding laundry, and a robot trying to fold laundry. Ever since the 80s, they've been trying to get robots to do this, folding laundry, and it's actually very complicated. It's easy for us, but it's very complicated. And we're going to take a look at a video where a professor at, I think he's in California, University of South California, professor of robotics, is talking about what why it's very hard for robots to do things that are so easy for us. Stacking blocks, picking out packages for Amazon, or folding laundry, something like that. Okay, so let me... I'm not going to watch the whole thing, just...
I've been doing research at UC Berkeley for 30 years with my students on robots. And in the next 10 minutes, I'm going to try to explain the gap between fiction and reality. Now, we've seen images like this, right? These are real robots. They're pretty amazing. But those of us who work in the field, well, the reality is more like this. That's 99 out of 100 times, that's what happens. And in the field...
Okay. So yeah, robots are very clumsy, and he'll go on to explain why by talking about different parts of the robot, the hardware of the robot. And this is where I got the information about Moravec's paradox, so we can skip that part. Okay, so he's trying to make robots less clumsy, and he's explaining why, some of the problems.
Career studying how to make robots less clumsy. Now let's start with the hardware. So the hands. Now this is a robot hand, a particular type of hand. It's a lot like our hand, and it has a lot of motors, a lot of tendons and cables, as you can see. So it's unfortunately not very reliable. It's also very heavy and very expensive. So I'm in favor of very simple hands, like this. So this has just two fingers, known as a parallel jaw gripper. So it's very simple, it's lightweight, and reliable, and it's very inexpensive. And if you're doubting that simple hands can be effective, look at this video, where you can see that two very simple grippers. These are being operated, by the way, by humans who are controlling the grippers like a puppet. But very simple grippers are capable of doing very complex things. Now, actually,
Okay, so why is a robot-shaped hand, like a human hand, why is that not very good compared to it's expensive, yeah, to make a robot look like, also very heavy. Good, yeah. Oh, did you have a different answer? Or no? Okay. Yeah, so to make a robot hand, you would think, oh, we need robots to do things that humans would do. So we need them to pick things up. So we just give them, model it after a robot. We'll imitate, or after a human. We'll imitate a human. But it's actually very expensive to get the robot to look like a human hand. They've done it, but it's very expensive and it's not as effective as the gripper. So he says simplicity is very important. You know, if you want a robot to not just entertain people, but actually be useful in doing a task, getting it to look like a human is not the most important thing, even though sci-fi has put it in our ideas, oh, we need human-looking robots. So finding ways, efficient ways, to keep things simple, cheap, money is very important, and also simple, cheap, and also effective, being able to carry out the task. Now, he has another
history, there's even a simpler robot gripper, and that's the suction cup. There's even a simpler robot gripper like the puppet, but very simple grippers are capable of doing very complex things. Now, actually, in industry, there's even a simpler robot gripper, and that's the suction cup. And that only makes a single point of contact. So again, simplicity is very helpful in our field. Now, let's talk about the software.
Okay, did you catch, what is the second part? What, did you catch that word? The second type of gripper. So we have the hand gripper of the two, but then there was one. How does something stick? What did they use? Did you catch that? This is a pretty good word. It's a very common word and device that is used. Grippers versus, he says, suction cups. Suction cups. Suction cups are used. They're not electronic. But they can, grasp things using, I guess, pressure, and getting things to stick. And so that is, we don't have suction cups as human beings, but that is a very effective and simple way that they can get robots to pick things up and move them. Okay, good. And let me fast forward a little bit about why, he's going to talk about why it's difficult for robots to just simply pick things up, like picking up items out of a bin, and why they're so clumsy.
It turns out that we can predict the motion of an asteroid 1,000,000 miles away far better than we can predict the motion of an object as it's being grasped by a robot.
That's really interesting. He says that we can predict the motion of an asteroid millions of miles away better than we can predict the motion of an object as a robot is picking it up. He goes on to say that there's so much uncertainty in physics, it has to do with physics, that the robot cannot kind of process that type of information. And so that's one of the reasons it's clumsy, that just picking this up there's so much physics involved that it's hard to predict what the object will do in response to the robot. We can program the robot, but we can't program physics. But as human beings, because we're very complicated, we can adapt. So if that falls, I can catch it or something like that. I know that from previous experience. Okay, so let's keep watching.
Now, let me give you an example. Put yourself here into the position of being a robot. You're trying to clear the table, and your sensors are noisy and imprecise. Your actuators, your cables and motors are uncertain, so you can't fully control your own gripper. And there's uncertainty in the physics, so you really don't know what's going to happen. So it's not surprising that robots are still very clumsy. Now there's one sweet spot for robots, and that has to do with e-commerce. And this has been growing, it's a huge trend, and during the pandemic, it really jumped up. I think most of us can relate to that. We started ordering things like never before. And this trend is continuing, and the challenge is to meet the demand. We have to be able to get all these packages delivered in a timely manner. And the challenge is that every package is different, every order is different. So you might order some.
Okay. So what does he say? What does he say is making people more interested in robots? What is increasing, or what happened that made people more interested in robots? Should I call on you, Eric, because you did your presentation on this? E-commerce, sorry, okay, yeah, e-commerce, and Eric did a presentation on how COVID changed businesses, and two other students. So this is very interesting. People, during COVID, things shut down, and it was very difficult to deliver packages. Well, if we had robots don't get COVID, we would be able to handle that situation more efficiently. So people are more interested now in robots than they were previously. They've always been interested, But now more than ever, people are taking more interest, putting more money towards it. And so you think things are advancing because of COVID. It's kind of a consequence of it.
Some nail polish and an electric screwdriver. And those two objects are going to be somewhere inside one of these giant warehouses. And what needs to be done is someone has to go in, find the nail polish, and then go and find the screwdriver, bring them together, put them into a box, and deliver them to you. So this is extremely difficult and it requires grasping. So today, this is almost entirely done with humans. The humans don't like doing this work. There's a huge amount of turnover. So it's a challenge. And people have tried to put robots into warehouses to do this work. It hasn't turned out all that well. But my students and I, about 5 years ago, we came up with a method using advances in AI and deep learning to have a robot essentially train itself to be able to grasp objects. And the idea was that the robot would do this in simulation. It was almost as if the robot were dreaming about how to grasp things and learning how to grasp them reliably. And here's the result. This is a system called DexNet that is able to reliably pick up objects that we put into these bins in front of the robot. These are objects it's never been trained on, and it's able to pick these objects up and reliably click.
And notice it has two grippers. I think one is the hand gripper and the one is the suction cup.
Clear these bins over and over again. So we were very excited about this result, and the students and I went out to form a company, and we now have a company called Ambi Robotics. And what we do is make machines that use the algorithms, the software we developed at Berkeley, to pick up packages. And this is for e-commerce. The packages arrive in large bins, all different shapes and sizes, and they have to be picked up, scanned, and then put into smaller bins depending on their zip code. We now have 80 of these machines operating across the United States, sorting over 1 million packages a week.
And he goes, I've showed you a lot of the funny videos where robots are clumsy and failing because it's pretty entertaining. But he ends the presentation, we don't have time to go into it, but with more hope and more, he thinks these robots are coming, maybe not the ones who can like in sci-fi stories, who can clean our houses and whatnot, but in terms of like warehouse sorting and a lot of other types of robots, he's pretty hopeful that they're coming. And of course, interestingly enough, the first comment, or one of the early comments on YouTube when I was looking this video up, is a guy said, I'm an Amazon worker, I want to know, or I'm come here to see what the competition is. And this is interesting to me because people, whenever there's an advancement in technology, there are always people who kind of have a fear that their jobs will be replaced because we're changing. But I think this has always happened. This has always happened. I don't know if you've ever studied in history class the printing press. Gutenberg in maybe I think 1490, when the printing press was invented, and people started being able to produce books at a very cheap cost and at a very quickly. In fact, some historians think this is one of the most impressive inventions in the history of our civilization because it spread knowledge, it spread religion, it spread all kinds of things to people because we can produce books more quickly. But there was a group of people who were so angry that the printing press was invented, they actually would burn down buildings with the printing press and chase out people who tried to fund this. Do you know what this group of people was? Could you guess? Who would want to burn down the printing press? Who would think it's a bad thing? Yeah? I'm sorry, can you say what? Nobility? Well, nobility were actually funding it. Oh, I'm sorry. They thought Gutenberg was a, it depends on who, but in the Middle Ages, there were people who would hand copy books. That was their job. They would hand copy books, if you had a book of Plato's Republic, you would read it and then copy it by hand. And they made money off of it. This was their job. So they didn't like the Gutenberg printing press. Maybe a similar thing, not as extreme, but a similar thing is happening today. People are afraid they're going to lose their jobs. But these advancements, in the long run, will probably be seen as a good thing. And so I just think I wanted to end with that note of I think this is normal. This is quite exciting that we're in this time where with these inventions like ChatGPT, AI, and robots. I have here some opinion questions about robotics that I'd like to hand out to you and try to answer. Oh no.
只有带笔。
我也要，老师我也要。
后来上课都没带课本，
我们只有带课本，
带手机都带。
带课本。
我带了整个书包了，我都没带，都带毛就够了。
优先申请。啊，你用
上课有脑就可以了。你带课本没带脑也没用啊。
里面没有。这是怎么回事？
上一半。
借黄牛。
Are you interested? Yeah. Okay.
哇，这毛笔啊。
Yeah, yeah.
那一只你可以用吗？
不知道。
You are?
好像可以。
可以。
And yeah, so we have about 12 minutes. There's two questions. What are some important tasks you hope to see robots are able to do? Should the government support advancing robotics? If not, are there more important things they should support? If so, are there things that are not as important that can be cut? And the last one is, what would you name your pet robot? That's not the most important one. Focus on the other two, but if you have free time, I think it will probably be creative things. So yeah, please work on this. I should have asked you, but is there a difference between the robotics and the robotics engineer? I don't know if you know that. I couldn't find it. So a robotics engineer. So like if I go on the university page, they say, oh, you study robotics and become a robotics engineer. But then they refer to famous like Moravec, they call him a roboticist. I don't know if it's an older term. I don't know. I didn't know. I couldn't find it, but people use. Yeah, that's fine. That's fine. I was curious if there was a difference, or maybe they're the same. It's just older term. Oh, my information was correct. Yeah. Astro, yeah. Yeah, he goes into more detail, like showing the robot trying to do it. He actually says that on the desk there could be sound that we can't see, or some little thing that's microscopic that we don't see that could be changing the physics. So it says that when the robot is the same motion, it gets different results. It's just very interesting how complicated it is. And it makes sense, like why robots can do things theoretically, like you get a robot to play chess, and you can't get it to figure things out. It's interesting. So TED Talk, I like.
不会用力本来涂那个铅笔写过。
只能可以感觉有些没写过，然后擦掉会黑黑的。
就你叫你那个，
我自己做那个词。
可以啊，那你要叫他什么？假如你要是机器狗，你要叫他什么？
And close.
第一次喜悦的时候，看4:30半。
不错。
Notch，
我先你。
加上网站上面有人做这个统计，然后有一些就比较久。
But yeah, it is.
Events like that.
Yes. That's a whole other robot.
Yeah.
而且也很帅。
Oh yeah, but the stories are very
You are.
Yeah, I don't think it's all science fiction. professor of biochemistry. But the stories are very interesting. So I find. But I don't And what's funny is that yesterday, I thought the show was actually in the magazine. The first room of the bed was made by Nicola Tesla. Some people think that this counts as the one of the first robots. And I'm like, oh, my cousin's going to learn about this tomorrow. But that was more about remote control.
在做表面，还是它不是3期，对，现在3次，然后就我就买给重要。带了吗？那轻轨都是不累的。地球都飞了，知道吗
Mickey Mouse, you know? Cyberpunk and Mickey Mouse. Oh, that's better. You already have Mickey Mouse? Oh, Disney. Maybe they will soon. Oh, really? But what about